Cox, and we would like to share with you research on user-friendly technology distribution and the language technology development pipeline. So first of all, I would like to acknowledge that this work has been possible thanks to the contribution of different members of the academic and the linguistic community of South Indonesian, especially some of the Indonesian of the institution of the South Indonesian Institute.
All right. So in this presentation, we would like to share with you research in the past years on how to create user-friendly technologies and speech technologies to support language documentation and revitalization work. And of course, with a focus on how to distribute these technologies in user-friendly ways as well. So first of all, I will introduce our work with ELAN recognizers, how we spotted some challenges on their distribution, and we decided to run a proof of concept to see how installers could help us with these challenges. So this research is framed on the context of language endangerment that I am sure everyone here is very familiar with. In the Canadian context, around 85% of the languages spoken in the country are endangered, with the resulting loss of indigenous knowledge, linguistic and cultural diversity. As a result, there has been many efforts in language documentation, revitalization, and maintenance projects. And in recent years, increasingly these projects have included the support of language technologies in them. And our research focuses on observing how existing speech technology resources can be made accessible to language workers and communities who don't necessarily have a large computational background. So this research actually focuses as well on I would say the area of decolonizing speech and language technology. Some research has focuses on pinpointing some colonial and harmful practices that exist in the development of speech and language technologies. Some of them are focusing on or having approaches that focus solely on data instead of considering the larger context of the language community. Having research that uses or focuses on creating gold standards with, of course, the corresponding prescriptivist views on it. And there are some challenges as well on the concept of universality in the access to knowledge, which may clash with some views of different community members on which cultural or religious knowledge should be shared among people who are not part of the community. So more specifically, some colonial practices that have been determined in language documentation projects have to do on the lack of access from community members to the result of these projects, also on giving the community members minimal agency on how the research takes place, conflicted ideas about access, which is what they just mentioned, and in some of these research models have been criticized for being one-sided in their participation of the community, where the community may participate in providing the data, but would not be involved in other part of the project, such as the creation of data sets or on developing the research in general. Instead, we would like with our research to support the self-determination of Native communities and their agency on the development of this language documentation and revitalization work. So that's how we arrived to our current research which has been developed as part of an existing collaboration with the Tsut Ina Gunaha Institute. This is an organization of Tsut Ina Nation that is located in Treaty 7, which is in Alberta, Canada. And you probably know this from a previous presentation in this workshop. This institute has been organizing active and extensive language revitalization, education, and documentation programs for Tsut Ina language, which include more than 100 hours of new language recordings each year. And one of the goals that have and that are happening in this institute are to incorporate these materials into a community language archive so that we can make these resources available for members of the community, and they can reuse it, for example, for their revitalization purposes. However, for that, we need to make this and the information in these recordings more accessible, which means making sure that there are existing annotations in both Tsut Ina and translations to a major language, in this case, English. Our previous research has shown that it is possible to use current speech technologies to help speed up the process of annotating these language recordings. For example, by segmenting and using automatic segmentation or even automatic transcription. However, what we would like to focus is how do we make these tools accessible to everyone involved? And the first step for this is using a software that is familiar for many users and not only computer scientists. In this case, we chose Elan, which I'm sure most people here are very familiar with. It is a time-aligned annotation. It is a tool for time-aligned annotation of audio and video recordings, which is very widespread in the language documentation and revitalization communities, and used by language communities in general for the annotation purposes. And we tried to implement some speech technologies, incorporate them in this software as recognizers, something that I'm going to show in the next slides. So in this case, what we tried to do was demonstrating that it is possible to distribute current speech technologies in accessible ways, and incorporating them into existing software tools, in this case, Elan. We focused on voice activity detection and on automatic speech recognition for Tsut Ina and for English. I will focus in this presentation only on voice activity detection, and we define this as as automatically segment audio into speech utterances. Our recognizers adapted to voice activity detection models. First, Voxeg, which resulted in Voxeg Elan, and Celerobad. And this is how it looks. A recognizer of Voxeg, in this case, looks like. So as you can see, this is within the Elan software. It is possible for the user to customize their use with some settings that allow it to adapt it for the requirements of their different audios. And that's actually the only thing that the user needs to do. It is automatically processed, and then the result of this speech technology appears as a tier on Elan. I am not going to delve into this as this is not the focus of the presentation, but we have done previous presentations with this, and you can find them available online. Our focus with this research was to create technology that was user-friendly. We defined that as technology that is easy to understand and to use, and it requires little to no training to be operated by the user. And there has been existing work that has focused on that by creating user-friendly pipelines for automatic speech recognition, or even other projects that have incorporated other speech technologies into ELAN. However, we wanted to look more in detail into these approaches and see whether they were truly user-friendly. So in this presentation, we wanted to focus on how these user-friendly technologies are installed. Is this user-friendly? And the answer is clearly no. At the moment when we started this research, we were distributing our recognizers using GitHub. And I'm sure for many of you who work with developing language technologies, this view is very familiar. These are the instructions of how you would need to install this in your computer so that you could use a recognizer. And if we analyze it a bit in detail, we can see that it requires some specific knowledge. For example, folder navigation of knowing where ELAN is and the specific extensions directory is where these recognizers need to be placed. It requires also knowledge of how to use the command line. In general, it required already having some requirements on your computer, such as having Python installed in the correct version, having a Git distribution. And these technical requirements all fell in the user side. And they were, of course, not some knowledge that could be expected by the average user. So that's why we decided to explore how we could expand the concept of user-friendly to include the distribution of these technologies. And for that, we created this proof of concept. For this, we chose to use to explore how one model of voice activity detection could be distributed for as an ELAN recognizer in a user-friendly way. And we created installers. The first step when you are creating an installer is to wrap the recognizer as an executable file. And then once you have wrapped this recognizer, you need to select the installer of your choice for the distribution part. So focusing on how we create the executable file, I would just want to illustrate how necessary this executable file is, because the average user will see that in these recognizers, we have many dependencies that need to be included in the same file. So you have ELAN wrappers, information documents, and the Python environment that is going to be used, and the system and dependencies that are required for this recognizer. This, as I said, requires some technical background of the installation of different packages. And with executable files, the user actually just needs to have one single file, which contains all the files, the Python version and environment and its dependencies. And that's the first part, the easy part. And then we focus on how to distribute it in the software, which is how to make sure that it is installed in the correct folder. For this proof of concept, we only focused on one operating system, which is Windows, and we use ANSYS for that. So these are some of the features that ANSYS have or are allowed. This is when you open the file, the resulting file, you would see, first of all, the option of which components you would like to install. Right now, we have finished testing Celero BAD only, but for future work, it would be possible using a single installer to offer different to offer the user to install different recognizers according to their interests. Another of the features of these installers would be that they can automatically detect the location of, in this case, the latest ELAN version that is installed on the computer. With also the possibility on the user side of browsing towards a different version of ELAN if maybe for some reason they want to use it with an older version. So as I said, right now we have a Windows installer working that has been tested for Celero BAD, the Celero BAD ELAN recognizer on the ELAN's versions 6.4 to 6.8. They are available for download on a shared drive, and the link it is available on the GitHub page and link that I sent on the slides. Our future directions of this project would be to target other operating systems such as macOS or Linux, and to include other speech technologies for this. But overall, I would say that this proof of concept allowed us to explore whether the user-friendly distribution would be possible. And yes, so then the next steps would actually be to advocate that the speech technology development doesn't only stop on having some solutions, but also on how users can access these solutions on a user-friendly way. Thank you so much. And I think there is time for questions.
Thank you very much, Lorena, for the amazing presentation. We have more time for questions and suggestions.